The second part of the test was geometric sequences and series. So number 6, it asked you to find the fifth term in the sequence 80, 20, and 5. And you could see that it was dividing by 4 each time, or if you could take 20 divided by 80, the previous term, that would give you the common ratio, which was 1/4. So the way you find the common ratio is you take any term in the sequence and you divide by the previous term. So in geometric, it's multiplying to get to the next term, or dividing. So it's dividing by 4 or multiplying times 1/4. You could double check that. 5 divided by 20 is also 1/4. And so now that you have the common ratio, you can continue, if you just need the fifth term in number 6, so you could continue to write this. So 5 divided by 4, or times 1/4, is 5/4. 5/4 times 1/4 is going to be 5/16. And that's the fifth term in the sequence, so that was the answer. Then number 7, the second number in the part 2 was write the explicit formula in terms of n for the sequence 1/64, 1/32, and 1/16. And again, to find the common ratio, if you took any term in the sequence and divided by the previous term, well, you're actually just multiplying by the reciprocal, 64 over 1. And that's going to be 64 divided by 32, which is 2. So the common ratio was 2, and the nth term is written as a1 times r to the n minus 1. So if you had a1 was 1/64th, so the nth term was 1/64th was the first term, times your common ratio of 2. And you just leave n minus 1 in the formula, so that's a direct formula. So any term you're trying to find, if you're trying to find the 20th term, you could substitute it back in for n and evaluate what the 20th term is. 8, which was write the recursive formula, and recursive means based on the previous term. So if you have the sequence 8, -4, 2, and -1, you basically take -4 divided by 8, which is -1/2. And then 2 divided by -4, which is also -1/2, and that's going to be your common ratio. And now that you have your common ratio, recursive means based off the previous term, and you always write the first term in the sequence for a recursive formula, which is 8. And then the nth term is based on that previous term, so you take the common ratio, which is -1/2, and multiply times every previous term to get to the next term. And so that's the recursive formula. And then we had number 9 asked you for find the sum of the first 6 terms of the sequence, 64, 16, 4. You can see that it's dividing by 4, multiplying times 1/4. So 4 times 1/4 is going to be 1, and 1/4, 1 times 1/4 will be 1/4, and 1/4 times 1/4 is 1/16. And that is 6 terms in the sequence. So to find the sum, you could just add all of those together, which would be 64 and 16 would be 80. And then you would have plus 5, that's 85. And then you have 1/4 and 1/16. So you basically have 4/16 if you've got a common denominator. If you multiply it times 4, that's going to be 4/16 plus 1/16 would be 5/16. So the answer was 85 and 5/16, or 85 point. Some people gave a decimal. If you just divide 5 by 16, you would have got the decimal. Now, they had a formula for the finite sequence of geometric, which was S subscript n, which was the finite. We'll put 6 in for the n. And the finite one was a1 times the quantity 1 minus r to the n. And I provided this on the formula sheet that you could have seen if you understood what you're looking for, and then 1 minus r. So this is going to be a1 is 64 times 1 minus, the common ratio again was 1/4, to the 6th power, because that's what you're trying to find. Make sure you only take that 1/4 to the 6th power, and then 1 minus 1/4. And you end up getting the same thing if you evaluate that to, you get the 85 and 5/16, or you can have it as a decimal. And number 10, if you had evaluate, these were infinite series for geometric series for number 10 and 11, so you could tell that because it said k equals 1 to infinity. And so if k equals 1 to infinity, you had to test one thing before you could even find the sum. Remember, this is a summation symbol, and you had to evaluate the common ratio. So on this one, the first thing you had to test is the absolute value of the common ratio greater than 1? If it is, then you can't find the sum. But this common ratio, remember, this was the first term, and this is the common ratio being taken to the n minus 1, or k minus 1 in this case. And so since it's less, the absolute value of negative 1/5 is 1/5, it's less than 1, so therefore I can find a sum of that. And the sum of the infinite series, if it passed the test and was less than 1, then you could find it by a1 divided by 1 minus r. So a1 in this case is 5 divided by 1 minus negative 1/5. So you have 5. This is plus 1/5, so 1 and 1/5 is the same thing as 6/5. And when you take 5 divided by 6/5, you're going to have 5 times 5/6. So basically the sum is 25/6 for number 10. And then, which when you look at it, it was also an infinite series. So you had k equals 1. And so k equals 1 to infinity again. So you could tell it was a summation symbol, or find the sum of this infinite series. But what confused students is it had 4 to the k minus 1. Well, your a1, that means you hadn't understood 1 here. That was your a1. Your ratio, common ratio, was 4. So the first thing you check for, remember that your common ratio is greater than 1. If the absolute value of that's greater than 1, then it does not have a sum. So that's all you had to write, was does not have a sum. You didn't even have to apply a formula. And that was all of this part 2 of the test.